In this example, we are going to be sketching a cosine function. So let's go through and list all of the different transformations that we can find in this equation. So we're going to first start off with our value of a. Now this is our value of a right out here, which means my a value is going to be 2. Next up, we have our k value. So my k value is right here. Remember, it has to be outside of the brackets. That makes my k value 1/2. Now for my d value, we have to be a little bit careful here because this is where my d value would come from, but we have to remember our general formula inside here had x minus our value of d. This is x plus our value of d. So I could actually rewrite this as x minus, to follow our general formula, negative pi/2. Because a negative times a negative makes that positive here. So in fact, my value of d is actually going to be negative pi/2. So that's something to be very careful of here. It helps you to rewrite it out like this, and by all means, you can go ahead to make it more clear for yourself. And finally, we need my c value. Well, typically the c value would have been right here, but there's nothing there. So that is equivalent to adding a value of 0. So that means my c value is going to be 0. And I can use all 4 of those properties to help me list all of the key features of a transformed cosine function, and then help me plot my critical points. So let's quickly review what each of these come from. So my amplitude is the absolute value of my a. My equation of the axis, or my midline of my sketch, is going to be at c. My max and min come from a combination of these, right? Because we're going to be starting at my value of c for both of them. But for my maximum, we are going to be adding my amplitude. And for my minimum, we're going to be subtracting my amplitude. Moving on to the period, or the length of one cycle, that's going to be equal to 2 pi divided by whatever my k value is going to be. And since we have 5 critical points, they're going to be evenly spaced apart. So they're going to be spaced by period divided by 4. So whatever this entire value of the period equals, we're going to divide it by 4, and that is going to be the distance between each critical point. Finally, we're going to be starting our very first critical point at our value of d. And from there on and down, we're going to be adding the value of the period over 4 to get the next point, and then cascading down to the next and next point. So let's use this to find all of our key features here. So my amplitude. Well, my a value was 2. So we're going to find the absolute value of 2. And remember, the absolute value bars just make whatever is inside here positive. Well, lucky for us, this is already a positive number. So my amplitude will indeed be 2. Next up, equation of the axis, or my midline. So that is just my value of c. And we said that my value of c is 0. Because it is an equation of the axis, it is that horizontal line, we have to describe it as y equals 0. Next up, my maximum, where I take this midline, 0 and 0, and I'm going to add my amplitude to get my maximum, and subtract my amplitude to get my minimum? Well, luckily these are pretty easy. So 0 plus 2 gives me a value of positive 2. 0 minus 2 gives me negative 2. So now I have my midline, my maximum, and my minimum. Moving on to the period here, or the length of one cycle, we have to take my 2 pi, because that's the length of the original cosine function without it being transformed, and I divide it by my value of k. Well, my k value itself is 1 over 2. So I have a fraction divided by a fraction. So this will actually end up being 4 pi. Well, how would that happen, you might ask? So let's see what that looks like. I'll actually do it down here. I have 2 pi divided by 1 over 2. Well, I can actually rewrite this as 2 pi using this division symbol, 1 over 2. Nothing's changed here. I've just used a different division symbol. Well, this 1 over 2 is a fraction, and we don't like to divide fractions. Instead, we like to multiply them. So to change this to a multiply, I would have to flip this second fraction. So what does that turn into? Well, 2 pi. This now becomes a multiply. And when I flip this, it is 2 over 1. Well, that just is 2. So 2 pi times 2 gives me that 4 pi that we ended up with right here. Okay, so that's just something to be careful of. We can remind ourselves how to divide by fractions. Moving on, we have to find the distance between each critical point. So we are going to take the value of our period, or the length of one cycle, which is 4 pi, and we are going to divide it by 4. Well, luckily for us, this is a pretty easy one, right? So that's the length of one cycle, or the period. We divide it by 4, and that means the critical points are going to be spaced out by pi. There's going to be a value of pi between each of our 5 critical points. Now that we have all of this information, we can now figure out the x values of each of our 5 critical points. And we're going to start off at our value of d. Well, remember we said up here that I'm starting at negative pi over 2. Well, I'm actually going to be starting right over here. So that's why that negative is really important, because we're actually going to be starting here, not at positive pi over 2. So again, very important to remember. Next up, for my second critical point, I take my starting, which was pi over 2, and I'm going to add the distance between each critical point. I'm going to add pi. Well, I have a fraction plus this. So to add these two together, they need to have the same denominator, since this is a fraction and this is not. So I could actually rewrite this as negative pi over 2 plus, if I were to rewrite pi as something with a denominator of 2, it could be 2 pi over 2, because that would reduce back down to pi. And now I can just add my tops. So negative pi plus 2 pi will take me out of the negative and bring me up to pi over 2. So that means my first critical point will be at negative pi over 2, and my next critical point will be at positive pi over 2, which makes sense because they are spaced out by a distance of pi. So to find my third point, I take this value right here, at pi over 2, there, and I add another pi. Or, to make it easier, 2 pi over 2. That's exactly what this is equal to. Which, adding those together, gives me 3 pi over 2. And then I take that new value, add another 2 pi over 2. Get my fourth point, so 3 plus 2 gives me 5 pi over 2. And we do that one last time to find my fifth and final critical point. 5 pi over 2 plus 2 pi over 2, which equals 5 plus 2 gives me 7 pi over 2. That and that. All right, so I've got all of my key features of this lovely transformed sinusoidal function. So let's take a look at what we've got on our graph. So first up, I'm going to plot my equation of the axis, which is going to be at 0, right here. And next, I need my maximum and my minimum. Well, I haven't set my scale yet, so let's do that. So let's make this 1 and that 2. So this is -1 and -2. Now that I've done that, I can set my maximum at +2, which is right here, and my minimum at -2, right there. So there's my max, my midline, and this is my minimum. And we typically do this as a dotted line. So let's make those dotted here. Right, just about. Lovely. Okay, so there's my midline, maximum, and my minimum. Now, I know that I'm going to be starting at -pi over 2. Okay, well, I don't know where I'm going to be starting yet, whether I'm at my max, midline, or minimum yet. So I have to take a look back, and I realize I'm dealing with a cosine function. Well, a cos function is going to look like that, which makes my first critical point up at my maximum, my second critical point at the midline, my third down at my minimum, my fourth back at my midline, and finally my fifth back at my maximum. So I can use that to plot all 5 of my critical points. So my first critical point is going to be at -pi over 2, and according to cosine, it's going to be at my maximum, so it's going to be up here. My next critical point, number 2, is at +pi over 2, and that makes my critical point at my midline, so at pi over 2, I'm at my midline. My third critical point is going to be down at my minimum, and the third critical point is 3 pi over 2, down at my minimum. My fourth will be back at my midline, my fourth critical point, 5 pi over 2 at the midline, and finally my fifth critical point at 7 pi over 2 is going to be back up at my max. 7 pi over 2 up to my maximum. So now I've got my 5 critical points, and I can sketch this out. That's looking a little bit better than the last one. Maybe. There we are there. So that is my sketched function with my 1, 2, 3, 4, 5 critical points.